Let's start with the simple thing that we can do to describe how the blockchain is operating at all. So usually when you want to write some client application or doing something in the web, you have some client which get access to some web server, authenticates somehow, and then server lets to do some action which user want to perform. But with the blockchain, it looks like almost like this, but it has one very important difference. With the blockchain, there is no any cookie or something like that, but only your transaction. And how do the blockchain authenticate you? You have a pair of a secret key and public key. You create a transaction like just usual RPC method, like do something, transfer balance, create NFT or something like that. And then you sign the transaction with the public key of the secret key, and server checks either transaction correct, either signed with your secret key with your public key, and then blockchain node of the server checks, do you have enough balance to perform this transaction? And here is the main difference. So actually, blockchain node is decentralized, but for a usual developer, for a usual client, it looks like just a web server which performs some RPC methods, some operations, and can be used just a very regular web server with one difference. There is no cookie. There's just a requirement to send a signed transaction. So how do we sign transaction? To sign transaction, we need some specific software, and we need a key pair of a secret and public key. Okay, let's start with the simplest way to sign transaction, to manage key pairs and so on and so on. Let's install specific extension to the browser. Let's go to the Polkadot.js org. It's the main website for all Polkadot.js libraries, code, and so on and so on and so on. Let's go to the extension page. So let's create an account for me. Okay, magic is done. The account is here, public key is here, and the specific 12-word mnemonic seed, mnemonic phrase is here. Copy it and say that I've saved mnemonic safely. I'll save it a bit later. And now pass to the next step. Okay, I have to create some name. Let it be a workshop. Password, workshop 2. And create an account. Yay, I have an account. This extension is very simple. It doesn't even have a balance viewer or something like that. It can be just a presentation of your accounts, and it can sign transactions for your web pages to be a third-party software like that. But what's important with the seed? Let's save it. This phrase called mnemonic phrase, it's a seed for your private key. So your private key can be got from this phrase. If you lost it, you will not have any way to recover access to your account. And this is the main difference with the blockchain. I can show it the phrase very free now, because I know that it's just a demonstration demo seed, and I can create them as much as I wish. It's not a problem. It's just a one-timer, just for the presentation. There will be some small amount of testnet coins, but it's not a problem at all.
So just let me put it in context. Since we're using the Opal network, and we'll talk about the networks later, the Opal network has a valueless coin. So in this case, even if we show you the secret, yeah, you can kind of probably connect to this account and take the coins, but they're worthless. So, I mean, but don't do it now during the presentation.
So, and now we can go to the specific page called Polkadot.js apps UI, refresh it. Now provide an access to the Polkadot.js extension. Yep. We see the address here. We see the address here. It's called like that. It starts and ends with the same symbol. So we know that it's this account, but it has 0 balance right now. So Unique have 3 nets, 2 main nets. Unique it's a parachain for a Polkadot ecosystem, and Quartz is a parachain for Kusama ecosystem. Both of these nets are main nets. It's production nets. The token is can be bought on exchanges for real money and so on. And we have a test net called Opal, which can be used for testing and so on and so on. And points are valueless, as Philip said. And we can just ask the Faucet bot to give us some coins. Let's do it. Let's copy our address. Okay, it's copied now. Let's go to the bot. We'll send a link to you a bit later. Press it, send it. Just a moment. Transaction, okay. And we see that our balance now is 3,000 of opals. Let's create a very simple front-end application very quickly. Let's use Vue for the demonstration because it's just the simplest way to show this necessary features. It doesn't matter which framework you use, Angular, React, Vue, Svelte, Vanilla.js, it doesn't matter. It's just for the demonstration sake. Okay, yarn create with minus template. Okay. For the workshop. And let's install the dependencies. Okay. Let's do the yarn dev as it requires to us. Yay. We have working application.
And Sasha, for the developers to replicate this, do they need to set up anything ahead, or is it just a vanilla kind of setup that you're starting from when using Yarn and all this? Yes?
Yeah, Philip, thank you. Developers should have working modern Node.js on the computer, and that's all. Yarn is just a very convenient tool to help us, but it doesn't require it. It could be done with the NPM. It doesn't matter right now. I just use Yarn because it's quicker and easier to show. Okay, we have an application. Let's go to the components and let's cut out all the not necessary, like this, this, and this, and this, and this. And
Well, that's
this.
boilerplate code. Don't be afraid, everyone. This is just things that gets packed into the package view as well. We're just deleting boilerplate code.
Yeah, it's just a boilerplate code which is not needed to our demonstration. It's just a demonstration of Vue capabilities. And we want to focus on our capabilities. Okay. Let's see. Yep, hello, Unique. We are here. So we have just a blank page to show how it works. Okay, let's start. Let's write a very simple and common mount processor. Mounted. Yep. Great. Like that. Yep. Hello, Unique. We are here. So what's next? Next, we have to start working with the tools to show that Unique can be operated like just like a very usual, very common third-party Web2 service. So for this, we have an SDK that I'll just create it. I have to install it first. So let's add all the necessary libraries. The necessary libraries are SDK, of course, Unique NFT SDK. All the links will be shown after the demonstration. NFT SDK, Unique NFT accounts, and Unique NFT utils. Okay. Now we have everything we need. Nice. Let's restart the server. Okay, const SDK USDK. Yes. After import, thank you. We need a base URL for the SDK. Okay. For the Opal SDK, the base URL will be like that. Okay, and that's all we need to start working with the SDK. That's all, just a base URL. For example, let's go and check the balance of our account. Like balance, it's wait SDK balance get, and I need my address extension. Please help me. Copy. Thank you. Like that. And let's print it out. Balance. Okay.
Alex, just one short question. The base URLs, we are currently working with the Opal. What are the options for the other networks if we're working on Quartz or Unique and so on? Where would people look up these base URLs?
Yeah, it's now documentation about the SDK. It can be easily found in our documentation. Like, yep, how to install section. And here are all the links to all the SDKs. And the command rule is very simple. The first parameter here is the chain name from the small symbol like Opal, Quartz, Unique, and very soon it will be Sapphire.
So thank you very much. So the very important here for the developers watching is this is actually how you switch through which network you're working. So this is why we say it's so easy to develop on the Opal and just switch into a production environment, Quartz or Unique.
Like
Thank
that.
you, Sasha.
Yeah, thank you. And okay, let's see what we've done now. Okay, we've just took an SDK and requested our balance for this account. We can request a balance for any account because blockchain it's a open world and decentralized, and anyone can get any info from the blockchain. It has no any hidden or secret parts. Just protected from access, but not hidden. Okay, and what's my balance now? Yeah, my balance now is 3,000 of opals. It's correct, and it's just like here in the Polkadot apps UI interface. Yeah, it's cool. Let's clean up the code a bit and move to another section. Okay, like that. So, but it's okay. We can get balance. We can, so for example, list collections, get collections, and so on. We'll do it a bit later. But the most interesting part is to not to read something from blockchain. It's easy. The most interesting part it's to ask blockchain to do something, to write some information to the blockchain forever, because from a very common point of view, the blockchain is kind of an eternal database. So how should we do it? We should get an account, create a transaction, and sign this transaction with the account. Okay, let's get an account. And because we have this extension, let's use this extension. Let's ask this extension to provide us the account. So for this case, we need a specific module called Polkadot from Unique NFT utils package. Okay. Wait. Polkadot. Now let's enable and load all wallets. Accounts. Let's watch what it provides. Okay. Now we refresh the page, and yep, here we see the specific window, which requires us to authorize this website in the extension. Of course, we'll press yes, and then we'll see that we have accounts. Yep. one wallet and one account. This wallet with this address. So of course we have only one wallet, the Polkadot.js extension, and we have one account in the wallet. Let's use it. And let's see what's here. Here is some specific information like extension found, account find to make a good interface, but here just very simple demonstration and we'll avoid it. We'll just say that everything's okay. We'll not write some extension specific checks. We'll just use the first account we have because there is just one account. And let's use it. Let's create some more some variable with more lifetime than just one function. Count. And let's save it to the variable. Okay. Okay, now it's here. So let's check not any balance. Let's rewrite this function a bit to get my balance. Okay. If it's my balance, we don't have to pass the address. We should somehow to get it. Okay, we have an account here, and we just need to get the address from the account. Okay, const account. Let's make it clean for the TypeScript, so that we don't try to do some magic. If there is no account, please throw such error. And let's replace this constant address with a dynamic one. And last one, let's add some button. Button get my balance. Yes. And again, I see my address. Let's check it's mine. Yes, 5FY. 5FY, it's my address. And with my balance. It works, and we are here. So what is Unique Network itself? It's a blockchain which is focused to work with the NFTs. The NFT, it's some amount of data. Usually it's image, but it's not should be an image. It may be any amount of data which is owned by some user. It's the most important part. So NFT is a thing which is focused around the ownership. The simplest interface of the NFT is an image, and let's create some NFT, which will be just a simple image, and to show how it can be done. But an NFT can be not only an image, but an audio, video, 3D object, or not media content at all. It's just it can be used for games, for something, for some records about shared ownership of something in real world called tokenization, and more and more and more. And let's just focus on the simplest option, an NFT with image, and we'll show how to create a simple and more complex NFTs. Okay, so now we know how to get an access to the account from the extension. Let's, I don't know, transfer some money to perform the simplest transaction, and transfer some money from me to, let's name it, let's transfer to me. Let's create just one more account.
While you're creating the account, for the ones that have just recently joined us, there's the point where we're at, which is very interesting. We're showing you at this point how easy it is to actually build through a very simple interface the calls that you would have in any interface that you have in like in Web2 environment, a button to do something, and we're connecting it here directly with the SDK to simply imply how very, very simple it is to assign a very complex blockchain operation which is encapsulated in the SDK, to a button to do something very, very specific here in your project. In this case, we're querying a wallet and also transferring at the same time. These are the basic built-in blocks of any kind of application interface that uses the blockchain to transfer value.
Thank you. Yes, let's do it once more. Let's remember my password. And yep, we are waiting. We see that there is less money. We see the operation in the block explorer here. It's a very bare metal block explorer. And we see that, okay, here's a balance transfer from my address to my second address. And here we got the status finally. Yep. And what's the most important thing here? Okay, let's request the balance of the origin once more. Yes, now I have not 2,999 Opal. Now I have 1/10 part less, because for every operation, blockchain takes some fee to perform the operation, because blockchain has to make some limitation to not to prevent the fraud transactions. So for every operation, we have to pay some small fee to the blockchain to perform the operation.
The gas.
So, in the Ethereum, it's a gas. And in the, Philip, thank you. In the Ethereum, it's a gas. And Polkadot is even better than Ethereum, because Ethereum has a gas and a very opaque model of, not transparent model of gas spending, it's on. And in the Polkadot, we have a very good benchmarking for the transaction costs. And for example, if we want to transfer one Opal again, yes, we make a transfer, we can say with a very good precision how much the transaction will cost, and it will cost 92 milli Opals, so 92,000 parts. So here is all the pricings are written out 1/10 part of Opal, Quartz, Unique. It's same price. The fraction is the same price for all our blockchains. So for example, if you pay for some operation 92 milli Opals, you will pay for the same operation 92 milli Quartz on Quartz. What makes sense. Okay, now we can transfer. One second, Philip, please. Now we can transfer money, and now we perform the simplest operation, a balance transfer, and now we made it signed the transaction to blockchain. Understand that we are really we. Yeah, Philip, please.
Thank you for the perfect clarification regarding the fees. It's a very interesting thing, and people need to know how specifically and the way it is formed in the unique network and the Polkadot system, and it's a very important distinction. Another thing I wanted to mention, that the unique signer is such a central tool in the SDK, because it encapsulates so many crucial aspects of the security and the encryption procedures, which would be actually quite a tedious thing to program if you went the manual way. So this is where the SDK shines in its kind of utility. Thank you.
Thank you, Philip. So now we have an account. Now we understand how to get some information from the blockchain, and now understand how to ask blockchain to sign something. The most important part is here, because we just provide some with kind of a dependency injection, some tool to sign a transaction. And what's the most important part? It's not even shown somewhere to the network. The secret part is encapsulated in this extension. Even this page cannot reach any access to the secret part, to the secret key. Only extension know An extension knows the secret key, all the secret data, and so on to sign your transaction, and it's super secure because there is no any chance for someone outside of your computer, without, of course, any malwares and so on, to get access to this. Even SDK doesn't know what is the private key, how to sign a transaction, and so on and so on. It just uses this part, which is a block of extension, to sign the transaction. To sign transaction without any knowledge of the secret data here. So let's do something more interesting. Transfer money is a very simple operation. It's cool, but we want to create an NFT. We are here to make some fancy image and to send it for a big amount of money. And to create an image, to create an NFT with some image, first we have to create a collection of NFTs. So any NFT belongs to some collection. There is no any NFT without a collection. So we have to start with the collection, and we have to create it. Let's do it. And let's create one more function. Const create collection. Asynchronous. Let's make one more button. With a collection. Let's copy this small piece of code to understand, to prove for TypeScript that we are not trying to do something not good. Okay, actually it will look like just this with a small difference in a specific argument. Okay, let's do it. Let's try to guess how to create a collection. Okay, const collection creation result. Of course, it should be asynchronous operation. It's obvious. SDK dot collections. Thank you. Creation. That's what I need. Submit with result. Yep. SDK has a very self-describing modules and functions and so on and so on. The most unusual thing here is just we have to call the submit with result because of nature of blockchain. So, for example, in some usual Web2 third-party API, we'll use like, I don't know, const results access post, and will be headers like that. And yes, and in the blockchain, we have not some authorization header, cookie, or JWT or something like that. We have a submit with result, which will provide signer, count unique SDK signer. Yeah, and the magic instead of cookies in the classic Web2 solutions. So in Web2 solutions, we use cookie, authorization tokens, and so on. In the blockchain, we use submitting the transaction and signing and submitting the transaction in the chronological order. Okay, what we need to pass to the collection creation function. Let's see. Okay, first of all, we have to pass the address of the transaction origin. It's a requirement for any transaction on the blockchain. Okay, let's do it. Oh, what I'm doing, sorry. Okay, next, it's still red. Let's see what is red. Okay, type address string is missing the following properties from the create collection body: name, description, and token prefix. Makes sense. Any collection on the unique blockchain has to have its name, its description. It's a very short, and it's very short, usual several letters string called token prefix. Let's visit Unique scan. It's a blockchain explorer on the Unique. And let's see to the collection number 1. Collection number 1. Okay. Let's do it in a quick way. Okay, it's substrate functions, the very first collection on the Unique chain family, on the Quartz, because Quartz was first unique blockchain on the Kusama. Okay, now we have basic data. We have symbol P and K, and we have some NFTs, some holders, some information about it. Okay, extended data schema, attributes, and so on and so on. So let's see that usually symbols are some letters like P and K, or for example, shell for Celebreaks, and so on and so on and so on. Name, description, and token prefix in the very end of the error message. Okay, name, description, and token prefix. Name, workshop demo, for example. Description, a collection of the demo, and token prefix. Demo. Okay, it's not exclusive for letters. We can create 1, 2, 3, and more collections with the same name, description, token prefix. The only unique thing in the collection, it's collection number or collection ID. And the blockchain will issue the collection ID on its own. We don't need to manage it because it's an auto increment number, and the blockchain will manage it for us. And let's bring the collection creation result first. Okay, what we have here, it's a very minimal amount of data to create a collection. Okay, let's just do it. And create a collection. This. Let's go to the blockchain explorer and see what's going on here, because here it will be sooner than here. Yep, collection created. Very nice. And it's created collection with the number 1812 and to our address. We are owner with the owner of the collection. We know it. Yes, collection number is 1812. Let's copy it and let's do a quick hack to look at the collection. Yes, we can request the collection via the SDK, but here it will be even easier to show what the collection consists of. What the collection consists. It's NFT collections. There are another type of collection like fungible and refundable collections, but today we'll say about the simplest collections like NFT name. It's our name, our description, our token prefix, and some specific settings of the collection like sponsorship, limits, and so on and so on and so on. It's very cool stuff for us, very specific capabilities, but let's see to the most necessary for us. It's collection ID and collection owner. And this is again our address. So we are collection owner. We can set the limits. We can set some permissions, anything. And the most important one, we can mint the tokens to the collection. But there is now some collection schema or something like that. We don't know how to operate the collection because here's an array called properties and it's empty. It's looks like very small thing, but it's one of the most important thing in the collection, describing what should logically be in the collection. Either it's an image, either it's a video or something like that. It's all described in the properties. So let's create a collection which will have some more information about the content we want to place to the collection tokens. We have a very basic information about collection, but let's focus on the content part. So what we can see here, it's a bunch of fields we can set, but the most interesting for us, it's the first one, schema. So the schema, it's a unique schema for the collection. Let's use it. And the schema describes how we should interpret the tokens in the collection because, for example, we can create 10,000 tokens in the collection and store all the data about every token. It's in the collection. It's very repetitive story. So we'll use, for example, like traits. Yeah, we have ice to the right, and a lot of tokens will have use trait ice to the right. Yep. So to store this string, pull the string on the blockchain, it's quite expensive because blockchain takes the money as a collection, as a transaction fee, sorry, with every byte we want to store on the blockchain. So we want to make it more optimal. And for example, for trades, we use enums when all of this big string will just compress to 1 byte of enum of the trait of this attribute. And then it will be much cheaper than to store all the traits manually. Also, it can be manageable because, for example, if we'll make some mistake in this trait, we can easily fix it later in the collection settings. And if we'll store all the string in the token itself, it will be sealed forever and it will be immutable. Here's two parts, the BaseURL part and the CID part. And okay, we need a BaseURL part here just to use it. And the URL template should be described in a very common for JavaScript way. So for example, we make the base URL part, and then we mark the place when we want to later put the another part of the URL with the infix, but we don't use $sign. We just make it in a single mustache. And that's all. But let's add the cover picture. It will be cover picture of our NFT collection or the full collection. And here's in the other part, we can use the whole URL, some URL infix, or to say the URL infix will be IPFS seed. And let's use this image again. And the SDK will understand that it should be combined together. This part and this part should be used an infix. So it will be replaced with this part and we'll get back the whole link of the cover picture. Okay, now we have all, everything we need except attributes. Let's create some very simple attributes. Let's have a version, of course, 1.0.0. Schema. Let's remember how it's done. Record string attribute schema detail. Yeah. Like and name of attribute. I don't know, like color. Either I know it will be array. Type should be string. Optional, no. Yes, let it be optional and let it be optional. I don't know, just as I wish. And to use some enum values to store the data more compact. Okay, again, we have a dictionary and we have, let's create some values. The first one should be red, of course. Red. Green and blue. Let's do it like that. Okay. Schema. Okay. Name should be to made like a boxed value with some object. Okay, now it's okay. I have given an attribute. Let's make. I guess it will be enough to make just one attribute. The more is just a complexity without any sense. Okay, now we have some strange looking tree, but it's just a schema to make the collection stored very in a compact and effective way on the blockchain and contain all the necessary data to be shown in any block explorer or to contain all the necessary data. Another way, we can just fold this block, and we'll see that it's the pretty old basic transaction like submit wait result, address, some params, signer, and that's all. So let's do it.
One more comment regarding this fantastic attribute schema creation here. You showed us you've actually done it manually. I want to remind everyone that there will be posted tutorials from our workshops from other sections where you can actually see how this is also solved programmatically when creating tokens, how to automate this and make this a tool. So do take a look at those at some point as well. But this is gold here, showing you manually how to actually observe this, how schema relates to the properties of the collection. Thank you for that, Alex.
Yeah, thank you, Philip. And I can add one word about why it looks so strange. It's made to make it very easily reproducible in any interface. For example, here you have very easily structured and ordered, very easily ordered structure. Here too. So, for example, it's for a experienced web or mobile developer, it's obvious that it should be some list of attributes, and it should be like a combo box or select or something like that, and so on and so on. And it's easily to understand how to build an interface on top of this schema. Let's create a collection. Let's run it. And transaction. Let's see what's going on here. Collection create. Nice. Next collection for our account. Let's wait until the operation finishes. That block is being finalized to show us the operation is done. Why do we have to wait so long time? Because of the decentralized nature of blockchain, we send a transaction to one node, and then all the nodes, or at least the most part of nodes in the blockchain, have to exchange this information, prove that everything is correct, that I'm not trying to full blockchain, and then they have a consensus that the transaction is correct and it should be performed and saved in the chain of blocks in some block. So every block have a time of 12 seconds, and it's done to to collect some transaction pool and then to process them simultaneously, and to have enough time between every node to exchange the information and understand that everything goes correct, and to have a consensus. What is the most important part of the blockchain itself? Okay, now we have the next collection, and let's see the collection. Okay, now we have collection schema. Let's see the collection schema. Yep, and it looks like what we've just saved to the blockchain, except that it's extended with some data. For example, we have image URL template here and IPFS here, and the full URL provided to us by the SDK. Thank you, by the REST service. And what's more important? What is more important? The schema. It's a logical schema of the metadata which should be stored in the blockchain. And the properties is the physical way of storing the data in the blockchain. So yes, we have properties in collection, and later we'll see the properties in the token. And what's important properties is just a very simple key value storage. And here we can see how the logical schema is mapped to the physical layer of storage. For example, we have some several keys: cover, picture, IPFS image URL template. We'll see everything of this here. And now we understand how it works. Okay, let's move. Let's create a token. Now we know the collection number, and we'll just use it as a hard-coded number. It's okay. In the real interface, of course, we'll pass it as we should, but now I don't think it's makes sense. Okay, we have an account and collection ID. Okay. Now let's mint a token. Okay. Tokens. Rate. Submit with result. Okay. Of course, address, first of all. And pass assigner. Collection ID. We know it here. And what we want to store here. Data. And the data is data which should be used with the collections created with a unique schema like this. Okay, for example, image. Image will be an object just like cover picture, which we have done previously. Now let's use just the same IPFS ID. Okay, we have an image. What will make more? Name, encoded attributes, and let's use encoded attributes. Oh, sorry, not this way. 0, and we know that 0 is enum of some values. And let's see to the picture once more. I guess the most color on the picture is, let it be red. Okay, now is 0 is 0. Okay, because first 0 is the number of the, actually it's a key of the attribute, and the second one it's a key of the enum we want to, one enum value we want to use. Okay, second result. I forgot to add the button. Token. Token. Okay. Yes, let's sign transaction once more. And let's watch. Yep, item created. Now it was much quicker because we got luck this time, and we've sent a transaction just before the block have been mined and the transaction pool has been flashed. Okay, it's a token and token property set. And what do we have now? We have a collection and we have a token. Token. Yep. And here we see the token. It's already decoded from the schema. So for example, there we've sent raw value, and now it has fully decoded object to get and rendered, for example, name, color, value red, just like we've seen it on the scan. For example, with this girl, traits. Yes. And we can imagine that it could be named traits and the value like eyes to the right. Yes, we have an image here. We have encoded properties of the token and so on. And let's see to the token properties. With the collection properties, it's simple. The collection properties is just a set of key value pairs, where key and value is just a bunch of bytes. With the key, it's a strict set of bytes. It's just a ASCII lower half. actually just the printable symbols like letters, numbers, so on. And the value is a set of any bytes, but here it's just string. So for collection properties, it's just a bunch of key value pairs, and for the token, the properties is actually a bunch of key value pairs. But what's the important difference? The collection properties can be set in any kind by the collection owner or admin, and then changed in any time. And with the token properties, it's a more complex picture. So in the collection, we have not only properties, but one more specific field called token property permissions. And this field sets and limit how the token properties can be set by whom, and when. So for example, key 8.0, its attribute with the key 0, like we've created it here, 0. Yep. And it's immutable and can be set only by collection admin. So it's created to be immutable, set by only a collection admin. Yes, there is much more settings to create token property permissions when the collection is being created, but it's default one, which prevents the scams. So the SDK made token property permissions for us just basing all our schema, which we provided in a very laconic way. It includes a big amount of some specific settings, which will create very different applications, from tokenization of some real estate to games and so on and so on and so on. And because it should be a very flexible system, we have to find a balance between laconic way and verbose way of specification of the attributes. So token property permissions can be set different. It can be set not like default one during the collection creation, but in the simplest way itself. So what's most important here? Collection have properties which can be changed in any time, and token property permissions which limitate the token properties, which can be changed only, which can be set mutable or mutable, which can be changed or not changed by the roles which are described here in the permission object. So it looks like a very simple RBAC actually.
That was a very nice explanation of how actually we protect the data and how we can control who changes what.
And now we have attributes and image and so on. And okay, our application is kind of very looks like something very set. It's not colorful and so on. So let's quickly add the token data. Okay, now we've minted token, we've created a token, and now let's get a token, because okay, now we use some JSON and in browser. It's a very easy to understand for developer, but it's not. It looks not cool for anyone except a developer. Okay, we know the collection number and we know the token ID. Oh, actually, I've used, I guess, token ID without printing it out, but here was the collection ID and token ID. Sorry. I just knew that because it's the first token of the collection, it should have number 1. Okay, const get a token. Think. Let's pass here collection ID and token ID without any tricks. No, what I'm doing now. Number, token ID number. So what we'll do here? We don't need an account here because it's just a GET request. We don't plan to sign anything. So we can just get back to the very beginning and get the balance. Okay, here we get account, but we don't need to. Actually, we can pass it like with a simple address, and we don't have to pass a signer to the SDK here. And we can just use the SDK without anything else. Const token.
Yes, we don't need to sign a transaction to ask, only when we're changing the state.
Yes, and because we don't need to sign, we don't need to get an access to their account. So, sorry. Like here, we make a very simple GET request and get the data without any authorization order like that. Here we don't need to pass an signer. Wait, SDK tokens get need collection ID, token ID, number of block we don't. Yeah. Let's just print it. What? Here we see the same JSON as we have seen here, like attributes and so on and so on and so on. So like, let's quickly print it out. Token ID by response. Like that. Now we have a variable to store the token, and we don't have to just print it. We want to store it token ref. Okay. Let's print it out. If ref, like that. The token. Yep. Now we see the picture of the token. Let's make it smaller. Yep, like that. And then let's print out the attributes list. Okay. After name. After volume. Like that. So yes, we see this NFT and we know its color, and we can even get its collection and number. Collection ID. Token prefix. ID. Yep. Demo 1. Let's add a fancy sign here. Yeah, demo 1, color red. Now we look like almost like this. one. Okay, let's print an owner. Let's print an owner. Yep. Now we're like almost a wallet for us. We own this token. We can show it. And for example, let's transfer this token to someone else. But it's everything is cool, but we do it all signing the transaction with the extension. But what if you want to do something programmatically without an extension? For example, only in a program way. For example, in Node.js. Okay, let's create a script. Let's use TypeScript again, and let's just use a signer, not from extension, but from some library. Import SDK and account carrying provider from URI. Yep, like that. And we have our seed phrase saved here. We remember it. And let's create an account. And let's print out account. Oh, sorry, I forgot about the wait. Account, get others. Yep. So let's do it. Like, let's add specific runner for some TypeScript. It's not about React. It's some specific TypeScript runner for TypeScript files. Sorry, yeah, at T6.
Again, in the example above with the keyring provider, I just want to stress how easy it is to actually access a wallet through the keyring provider and immediately get a handle to the address and all the funds and resources and start manipulating the contents from there.
Yep, thank you, Philip. And now we have an access to, yes, let's underline it once more. We have an access to the SDK signer from the extension in one line. And we have signer, actually it's a signer for the program way, again in one line. So we have to just call from URI and from mnemonic method will work too, because it's just a very simple mnemonic without any derivations or something like that. Okay, 5FY, okay, it's my address, I know it. Let's move. Count SDK, and you know, that sound, oh, sorry. Let's copy it. I don't want just to repeat because I want to copy this part. And we can provide a signer right here. We don't have to specify it every time. We have two options: provide it one time in the constructor, and then we can change it, overriding providing signer this way, or don't change it, just to use the provided from in the constructor, or to provide it every time later as we did it before. There are just two ways. Okay, signer account. Yep. And let's do some transaction like const token transfer result. Like I think.
Look at how simple the SDK call is. Actually, when you look at it, it's the first term is just what network are you talking to, and who am I? Like, who is talking? So that's all you need to initiate the SDK. The only two parameters, and you're off to the races.
Yep, yep. And you can say the second parameter here or later. It's on your own. It's up to you. Okay, SDK tokens transfer. It's just easy because I don't know that I know that I want to transfer tokens. That is just a reverse order SDK. What tokens? What I want to do? Transfer. Okay, and submit with result again. Address, account, get address from. I'm not sure that I have to say from. I want to say collection ID. I just remember it. Token ID again. And two. Let's use our second guy, workshop 2, to be a destination for the token. Okay, it's enough. I have now token transfer result, and let's print the result of it. So, okay, let's print information and let's to transfer the token. Okay. And now let's click to the Explorer and let's wait for some transaction. Yep, common transfer. It's our transfer from one our account to another our account with our collection and our token. And of course, to transfer one part of one because it's NFT, it's undividable. Okay. Now here we have the result. Okay. Transaction succeed. Collection ID, token ID from 2 succeed. It's okay. We know it because it have good parse result. And let's get a token once more. Okay, now it's address 5FY, and we expect it should be 5FRY. Let's do it. Get a token. Yes, the new owner is 5Fry. Now we can manipulate with the token. This way we can mint a token, we can set its properties, we can transfer the ownership on the token. And again, if I'll try to transfer the ownership, the transaction will fail just because I am not the owner of the token more. Because this address is not owner of the token. No transaction, it's not our transaction, someone else. Oh, parse, sorry. I have to print an error here. Once more. It's not even in the list because it's not a successful transaction. And the blockchain will not print it because it's not in the list. It's rejected by the blockchain.
Oh, thank you for that comment. That's a very good catch. Very important thing to know.
Yeah, like if you've sent, I don't know, for example, request to some server with someone else cookie, not your cookie, and server will just reject you because, okay, man, it's not your stuff. Yep, no permission to perform the action. Why not permission? Because it's not our token, obviously. Okay, I guess that's almost everything we've wanted to show to you today. Working with the blockchain explorer, how to get this data, how to get how to work with the scan API to get the JSONs and so necessary data to build such interface and so on and so on. It's out of the scope of today workshop, and it can be found in the documentation, for example, the tutorial section, how get and display NFTs and collections, like this. Or in the section wallet integration, which describes some another examples of how to operate with the scan API. So thank you very much, Philip.
Alex, would you be willing to provide a link so that the ones who watched this presentation and the ones that watch it in the future can kind of just download it in their own leisure while learning how to apply this?
Yes, we'll publish this workshop in some repo in our domain. Yes.
Great. Okay, so let me do a little bit of shorter resume and we can close this workshop. Alexander, that was a phenomenal presentation. We tried to do a very, very kind of specifically oriented presentation for the developers in this case, for the developers that are very used to working with Web2 concepts, creating interfaces, buttons, and so on. So the main idea behind this presentation is, right, if you know how to create any element of the interface and you know what you want it to actually do, that is, if you want to create a button to get a balance, or a button to create a collection, or a button to mint a token, we wanted to show how this is done hands-on live coding style, like when you're coding, what it looks like, what calls you made. And we wanted to show that it's actually very simple to get very, very quickly operational in those terms. So in a sense, this is like we mentioned it often, zero to hero, but really here is like a really good kind of presentation of how, if you just sit down and go through the steps, suddenly you're able to create a complete interface, a standalone dApp that is interacting with the blockchain. You're accessing the data from the blockchain. You're interacting with the blockchain by creating collections, tokens, and so on, and all this through a very simple interface, and using JavaScript and using the SDK, which makes it very practical to start creating new things. Thank you very much, Alexander, for this presentation. Thank you, everyone, for coming along and observing this. I hope this was a good presentation for everyone, and that it will help you really get cracking on the new codes, creating dApps.